All right, guys, so let's take a look at the warm-up and see how to solve it. Okay, as I mentioned a few minutes ago, on the test, you're going to see something just like this. Okay, you're also going to have the table, okay, to help you solve the problem, but you're going to have to fill in these 4 lines, and that's what I'm going to grade. Did you get the 2 equations, and then did you get the people's ages? All right. Okay, so what's the first thing we always do in this kind of problem? Write the names. Okay, put the names of the 2 people. Paul, Kate. Is it Kate? Kate. All right, after we put the person's names, what's the second thing we do? Antonio?
In row 1, you put like the variable, you put P.
Yeah, pick a letter for Paul,
Okay.
P, and for Kate,
Okay.
we'll pick K. Okay, so we got the names, we've got the people. Now, what's the third thing we do? Set up an equation. Okay, this is going to be the first step that you actually can get credit for. Okay, where does this first equation come from? The first sentence. Okay, the first sentence says Paul is 3 times as old as Kate. Can anybody tell me how to set up that first equation? Remember, first equation comes from the letters right above it. So you're going to have P and K in there somewhere. Josh? P equals 3 times K. All right, so if you write this down, that's the first thing you get credit for. That's equation 1. All right, what's the next thing we have to figure out? Okay, we have to figure out, there's 2 kinds of problems. This could be about the person's ages in the something, or it could be something else. What are your 2 options? Future or past. If it's a future problem, what operation is the future? Addition, right? How old will you be in 2 years, right? You'd add 2. What if it said years ago? What operation is that? Subtraction, that's the past. Okay, is this problem about the future or the past? Future. Years from now. How many years from now are we talking? 14. So we put a plus 14, and now I want to know Paul's age 14 years from now. If his age now is P, what do you do to get his age in 14 years? Ariel? P plus 14. Now, same with Kate. How old will Kate be in 14 years? Yep. K plus 14. Now, this is the second thing that you can get credit for on the test, equation 2. Where does equation 2 come from? What do you read to figure it out? Kyle? The second sentence. 14 years from now, Paul will be twice as old as Kate. When you write the equation, where does some of the stuff that you're going to put in the equation come from? It comes from right here. You're going to have a P plus 14 and a K plus 14. You're not using just a P and a K by itself anymore. That was for equation 1. All right, so 14 years from now, who's the first person we see in the sentence? Paul. And how do we represent Paul? In the future, right? Because it's 14 years from now. P plus 14. Paul will be. What is will be? Equals, right? Just like is in the present tense, will be. Paul will be twice as old as Kate. So how would I write twice as old as Kate? Okay, start with a 2. I need parentheses. And what goes in the parentheses? K plus 14. Okay, that is equation 2. 2K plus 14. Okay, if you just get those 2 things, you get half credit. Right? Now, if we can figure out Paul's and Kate's age, then That's how we can get full credit. All right, what's the next thing we do? This is the big thing that we learned last week. One word, begins with an S. Substitute. So now we're going to substitute. What equation are we going to change? Are we going to change equation 1 or are we going to change equation 2? We're going to change equation 2. What letter is going to get replaced in equation 2? K or P? P. We're going to replace P with what equation 1 says to change it to. So what are we going to change the P to in equation 2? 3 times K. So we got 3K plus, Dominic, can you tell me what comes next? Anybody help Dominic out? What comes after the 3K? There's no calculation at this step. You're just copying, now you're just copying down what you had. Hannah? Plus 14. Okay, keep going. Equals 2. Yep. K plus 14. Now, at this step, and Mr. Roy mentioned this too, you should only have one letter in the problem. It might appear in a couple spots, but we just have a K. The P is gone. Okay. So now, from here, we just solve it. Emma, what's my first step to solve that? Yep, we're going to distribute the 2. Is that going to change anything on the left? Nope. So we're going to keep that the same. How about Sabrina? When I distribute the 2, what do I get on the right? 28, good. Remember, when you distribute, make sure you do it to both. Some people will distribute 2 to K, and they forget to distribute 2 to 14. And then it messes everything up. Okay, so that's good. Antonio, what would I do next?
You solve, or you substitute?
Well, we already substituted. That was this equation right here, so we already did that.
And to solve that equation, Antonio, what would you do?
I would try to get rid of the number by the variable.
Yeah, eventually, if we have a number by the variable, we're going to do that. But first, we got to get all the variables
Oh, by themselves.
on one side.
Oh, so minus 14.
Okay, yep.
And you can't do it to 2x because it's not like term, so you use 28.
Yep. And that leaves me with 3K equals 2K. 28 minus 14 is 14. Now, I still got to get all the variables on the same side. So how would I do that? Careful, not minus 2. 2K. Minus 2K. That cancels out. And this has happened in a lot of the problems. I don't know if it's always going to happen. But 3K minus 2K, you're just left with 1K. Okay, this is the step where you would have to divide to get K by itself if there was a number in front of it. But there isn't. So we get K equals 14. Okay, so once you get that answer, don't forget to go back up. Put it on the line. K is 14. Okay, so for this, you'd get 3 out of 4, 3/4 credit for the problem. Okay, last thing we need to do is find Paul's age. Okay, so which equation here, equation 1 or equation 2, would we use to find Paul's age? You can use either one, but one of them is easier. Yeah, equation 1, because it already has P by itself. Paul equals 3 times Kate. So Paul equals, how old was Kate? 14. And 3 times 14, what is that going to give me? 42. Okay, so Paul is 42. Okay, and that's the 4 things that we're going to look for on the test. Does anybody have any questions on that? Okay, you will have this template on the test. So every problem, you can use that, and it kind of organizes what you have to do, and it leads you in the right direction. Start with column 1, then go to column 2, and then you have to do your substitution. All right, so I said we could do one problem from the homework. Yeah. Okay, so why don't, take a look at your homework, pick out one question. One question that you thought was tough.
What number did we decide on? The homework. Huh? 4? All right, Ariel says 4. Is everybody okay with 4? We do 4. Well, Wilma? Wilma Flintstone? Huh? We okay with doing number 4, guys? We're okay with this one, Wilma? All right, so someone tell me, I want to fill in these 2 boxes for name. Someone raise their hand, tell me what they wrote. Nini? Wilma and Josh. I like it. How about Derek? I know you might not have done this one, but that's okay. Can you tell me what to write here for the single variable?
W and J.
W and J. Very simple. W and J. All right. Does anybody want to tell me, how about Isolis? Can you tell me what to write for the first equation? Okay. Like it so far? Yes, perfect. J minus 2. Guys, big thing with this. And Eastlese are exactly right. All right? Where it says younger than, just like what Nini wrote, what does younger than mean in math? What's it going to translate to? Subtract, right? All right, it'll be minus. Now listen to me. Tomorrow on the test, when you see younger than, you need to make sure you put the variable first. If I had this, if I had W equals 2 minus J, that is incorrect. That's not the correct setup. You need to make sure when it's younger than, the variable needs to come first. So Josh, right, needs to go first. So it'll be J, whenever it's younger than, whatever the person's name is, Josh, Pete, Joe, I don't care. That variable has to go first, then minus however many years younger, however many years younger they are. So younger than means minus the just like we say decrease by 2. A number decreased by 2. We put the variable first, and then we put the minus. So when it's younger than, you need to make sure that you put the subtraction second, and the variable you're using to represent that person's name needs to go first. That's a tricky one. So be very careful. We'll probably see that today when we review in class. All right. What should I put in this box right here? Row 2. Ashley? Minus 12. Ashley, how do you know? Yeah, when it's 12 years ago. Guys, all you need, that first phrase in the second sentence, right? That's going to tell you if you're in the present, if you're in the future, or if you're in the past. In this case, we're in the past. When we say years ago, we know it's going to be minus 12. Now we got these 2 boxes. Trenton, what would I put for those 2 boxes? W, I'm just going to put W minus 12. And then J minus 12. All I'm doing is taking the single variable that I already have and going to minus by 12 because it's 12 years ago. All right? This is when it gets a little bit tricky. Somebody want to tell me how to set up my equation 2 for the past? Josh? Yeah, W minus 12. You good? You're good so far, you're perfect so far. Yeah? J minus 12. There we go. There it is set up, right? 12. Once I put my minus 12 here, I don't care about that. I don't care, that 12 years ago, I don't care about that anymore. Oh, that's not working, I have no idea. I don't care about that anymore. All right? She, which is this sentence, in that second sentence, what am I dealing with? Past, present, future. In that second sentence, what am I dealing with? Past, present, or future? Past, right? Because it's 12 years ago. Well, I said this to you guys on Monday as well. When you're setting up your equation down here, use these boxes, right? Wherever you see Josh or he or him, it's going to be J minus 12. Wherever you see Wilma or her or she, it's going to be this. Use these two boxes to set up your information, right? And Mr. Hager just wrote in equation 1 and equation 2, right? First one is W equals J minus 2. Second one is W minus 12 equals 2, parentheses J minus 12. All right, that's when it gets a little bit tricky. Somebody want to tell me what they wrote or what you need to write when you set up your equation to solve for one of the people? Anybody want to take a shot at that? What you think the equation would be to set up? How would you set it up? The whole thing with only one variable. All right, let's back it up then. What letter am I going to substitute for?
Take the W that's in the second equation,
Okay, this.
and then you're gonna like substitute it for the first equation.
So what am I going to put here?
J minus 2.
Good, Shannon.
What did you do?
Hager's like, oh, I don't know what he's doing. Hold on, let's try this. How much should we get? Whoa. Wow. There we go. There we go. All right, so W is going to become J minus 12. I mean J minus 2. So, Hannah, what am I going to write here? J minus 2. Whoop, hold on. J minus 2, okay. Careful. So we got this. I'm taking this, putting that in for W. I did that. J minus 2. Minus 12. Keep going. Equals 2. J minus 12. Good. Now, this next part. Even before, because usually we get to this part and we can just distribute. But this problem's a little bit different. I could distribute right away, but there's something else I could do first. Anybody think they know? Josh? What are the like terms, Josh? Negative 2 and negative 12. When I combine them, Josh, what do I get? J minus 14. Like the minus is the negative, right? Emma, what do I do now? So I did this. I combine my terms on the side. I got this. Distribute. When I distribute, what do I get?
You get 2J.
Good. 20 what? 24. Good. Thank you, Emma. Okay, good. Now what? Anybody think they know B? You know what to do now?
You want to get the J's, I would minus the 2J to the other side.
Okay, you could do that, and you're not wrong. What I would do is I would subtract J. When I get to this point, I want to move the smaller variable. All right? So 1J is smaller than 2J. So to move that, Bay, what would I have to do?
Minus the 1J.
Minus the 1J, right? From what?
Yourself.
Yeah, and match it up over here. Only, What would the reason, why would I subtract the subtract the J instead of the 2J? Anybody think they know, Ashley? Yeah, if I did that, you're not wrong, you're just gonna be dealing with negatives. I mean, you could do that, but then it's gonna be a little bit more, a little bit more difficult. This will cancel out. Here's my equal sign. On the left-hand side, over here, what am I bringing down? Careful. Negative 14, good. 2J minus J, or just J, means the same thing, minus 24. I got one more step. Marissa, what do I do? At this point right now, I got negative 14 equals J minus 24. Think you know what to do? Add 24. Why did you add 24, Marissa? Yeah, when I get to this point, I want to isolate the variable. In this case, it's J. Isolate means don't do anything to the variable. You're not going to do anything to that. Nothing at all. Whatever's on the side with that variable, that's what you want to get rid of. Never touch this. This is fine. Don't touch it. I'm going to add 24 to 14. I got my equals. This cancels out. On my right-hand side this time, what's going to be left? Just the J, right? I'm just bringing that down. Anybody think they know this? Negative 14, positive 24? 10. Now I can divide? Now I can divide?
Yes.
Why, Nini? Yeah, the variable, there's nothing, I mean, you could do this, like 10 equals 1J, divide by 1, J equals 10. If you plug 10 divided by 1 in your calculator, you would get 10. You don't have to do that, but I'm saying sometimes you guys do that. That's fine. And what Mr. Hager just did is, he brought the 10 and wrote it in for Josh's age. All right, so now, anybody tell me what to do now? Anybody have any idea what to do now? Ashley? Wilma?
Yeah.
All right, I want to solve for Wilma. What equation would I use? The first one. So all I'm going to do right now is actually just write out that first equation. W equals J minus 2. Talking to what? W equals 10 minus 2. So what Ashley did is, she took the 10 and she put it in for J. All right? You're always going to be plugging back into that first equation, because that first equation is always going to have that variable by itself. All right? We could plug it in over here, but then we're going to have to move stuff. With this, it's simple. Plug in the number, do the arithmetic, done. You don't have to move anything, you don't have to isolate, there's no distributive property, none of that. Plug in a number, you can plug this in your calculator, or do it in your head, it doesn't matter. How old's Wilma? 8. Mr. Hager's going to go back up. He's going to bring that up to the top. And there we go. All right? That's it. So it seems to me, when I walk around, guys, you can tell me if I'm wrong, but when I look at this right here, the box, in terms of filling in the boxes, I think everybody's pretty good with that. Is that true, or everybody feels okay with that? All right? Now, what we got to get to today when we practice is, now we got to really work on saying, okay, once I get to this part, whatever variable is circled here, I'm plugging in this information for that variable in the other equation. I'm taking the information from equation 1. I see in this one, W circled. That's the variable I want to substitute for in the other equation. Find W in equation 2, plug it in for this. You're always going to plug in the row 1 equation to the row 2 equation. That'll never change. But the ones we've done so far, guys, a variable has always been by itself. All right, we're going to do a couple, at least 2 today. I'm going to do one with you right now where it's not, the guy's not, one of the variables is not by itself. And Mr. Hager's going to give you guys the guy who knows right now. So, I'm looking at this one, and I'm seeing right now that's a little bit different from the ones that we've already done. Just based on that first sentence. Why is that one a little bit, obviously the names are different and the number values are different, But how else is it different from the ones we've already done? Have you any idea? Shannon?
Because it starts off already telling us.
Yeah, because the ones we've done so far, right, that first sentence has always dealt with the what? And the problems we've done yet, the problems we did on Monday, the problems we've reviewed today, they've always started with what? The people have always been dealing with the people's ages when?
First.
In the present. All right, we've always been dealing with the people's ages in the present. This one's a little bit different. All right, Shannon, how did you know that you were dealing with, how did you know you weren't dealing with the present when you looked at this problem?
Because, it says in 12.
In 12 years, there it is right there. So now, we have to be careful. Because when we set up our variables and our unknowns and our equation for the present, where do we always write them? In what row? For the ones for the present. Like when it's just a single variable here, single variable here. What row do we always set those up in? The first row. We always put it here. Always put it here. All right? Because the first sentence has always been dealing with the present. This is going to be different. All right? So I have to write something in. All right. Based on this right here, in 12 years, I have to write something in. Somebody tell me by raising their hand. Where am I going to write it? It's in 12 years. Isolis? Row 2? Where in row 2? The first box. Isolis, what am I going to put in the first box? Plus 12. Very good. Plus 12. Good. All right? Now, so we're doing a little bit different order now, because the first sentence is dealing with past or future. Am I dealing with the past or the future here? Future, right? 'Cause it's in a certain amount of years. But I can still, Mr. Hager, I'm doing right now, I can still fill in the names. Babe, give me one name I'm going to fill in. James is the first one. So you want me to write it? Okay. I got James. All right. What's the other name? Maggie, what's the other name? I got James. What's the other one? Clyde. Now, even though I'm not dealing with the present in my first sentence, it doesn't matter. I could still fill in my variables. How would I represent James, even though I'm not dealing with the present right now, but how would I represent James? What would I put? J. I'm always going to have the single variables in this first row. J there, and C for Clyde. So even though I'm not dealing with the present in that first sentence, I'm dealing with the future, because it's a little bit different than the ones we've done. This isn't going to change. These are still going to be the single variables. Aiden, what am I going to write here? In this box right here? Perfect, J. Take the single variable, and because it's in a certain amount of years, I'll add a certain amount of years to it. Derek, what about Clyde?
C plus 12.
C plus 12. So, I wrote this information here, right? This is James, this is Clyde. Where am I going to use this information? In the equation. This is going to deal with the first sentence. So what does that mean? So in that first sentence, wherever I see James, what do? Huh? But remember, the first sentence is dealing with the future. It's a little bit different.
Oh, yeah, add.
So what am I going to write, Antonio? Wherever I see James in the future, what do I write?
J plus.
Yeah, wherever I see James in the future, I'm going to write J plus 12. What about Clyde?
C plus 12.
Yeah, C plus 12. Wherever I see Clyde in the future, he's represented as C plus 12. Once I get this plus 12 filled in, if it's in a certain amount of years or a certain amount of years ago, that's all I need that for, nothing else. I just needed it for the top of that, for the top of row 2, whether it's past or future, doesn't matter. Once I do that, it's done. I don't need it anymore. All right? So, let's set up our equation for the future. what's the first thing I'm gonna write for my future equation? What do you think, Maggie?
James
So James, and we're in the future, so what's James in the future?
will be.
Okay, I know will be, I know, but James, right? And I'm talking about James in the future, right? How am I representing James in the future? So James in the present is J. What about James in the future? You have it written on there. It's written up on the board. So here's James in the present.
Oh,
What about James in the future?
put it in the.
I put in the second column, I agree. Well, how am I representing him in the future? This is him in the present. What about him in the future? Where would I find that information? Right here. Yeah, J plus 12. All right, so I'm setting up the future right here. Wherever I see James in the future, I already have it all filled out right here. That's James in the future, Maggie. J plus 12. Now, Maggie, you were saying something about will be. All right, so I got James, then we got will be. What's that mean? Equals. Okay, good. So I did James, check. James in the future is J plus 12. Will be, like Maggie just told me, equals. What's the next piece of information that might be important? Ashley? Twice. What should I write? 2. What else could I do? Start a parentheses, right? Good. Twice. Twice is all. We got all that. Good. Fine. What's the last thing I'm going to put? Me? C plus 12. How'd you know, Nini? Yeah, Clyde. Remember, we're not dealing with this first sentence, dealing with the present. I'm sorry, with the future. All right? Here's my information for the future. Where I see James in the future, J plus 12. Where I see Clyde, in the future, C plus 12. There it was. James was first. James is J plus 12 in the future. Will be is equal. Twice, I'm going to put a 2, stop my parentheses. Then I have Clyde in the future. Clyde in the future is C plus 12. Okay, good. So now, like I said, it's reversed this time. All right? The past or the future sentence came first. It's a little bit different than what we've done so far. Now I'm dealing with the present. The sum of their ages now is 76. What does sum mean? What math operation? Add. Sum means add. The sum of whose ages? Josh? James and Clyde. James and Clyde when? Present, future, past? How'd you know present? It says now, right? So, James, the sum of James and Clyde now. How would I represent the sum of James and Clyde now? I don't know how old they are, but I have information there that I can at least write in to get me on the right track. What do you think, Josh? Say again? C plus J. Yep, C plus J. Notice, we got this line up if necessary. All right? C plus J, okay. Anything else I need to write there? Anything else I have to write? So I did the sum of their ages. I got that represented, C plus J. Anything else I need to write? East? Yeah, is 76. C plus J is 76. Now I'm all set, right? I can just take this and plug it in. Who says I can just take what's here right now and take it and just plug it in? So I see nobody raising their hand. So someone's going to have to tell me why I just can't take that information and plug it in. What's wrong with this? Why can't I just take it and plug it in and substitute? Shannon?
Because J is in 5. Or, yeah, because it's in 5, so.
Yeah, I got C and J on the same side. Like when we did substitution last week, right? We might have had like x minus 2y equals 5, right? I couldn't substitute because neither of the variables was isolated. Okay? Same thing here. I have neither variable isolated. Can somebody tell me what I need to do to isolate one of the variables? Go ahead, Shannon. I can subtract C I can subtract J. You're not wrong either way. You can do either one. So you want to subtract, what again, Shannon? I forgot you, C. I'll minus C here, I'll minus C here. So, on the left-hand side of my equal sign, what's the variable that's isolated now? J. Equals, what am I going to write in parentheses? 76 minus C. I just took the C, I subtracted it so I can get J by itself, and subtract it on the other side. Just like last week, we had to get an extra Y by itself to be able to plug in. Now I'm ready. So, what variable, Dominic, I want you to look at this, all right? What variable will I be substituting for? Look at this. What variable will I be isolating for? J, right? Where's J in my row 2 equation? Right at the beginning, right? So I'm going to circle that. When I come down here to set it up, what is J going to become, Dominic? 76 minus C. Excellent. So I got that all plugged in. After that, 76 minus C. What should I write? What's the next thing I should write? Ashley? Plus 12. That's good. So I got that side all taken care of. Nini, just give me the next thing only. Careful, you missed something. So I wrote the 12 in. Something really important that I don't want to skip over. Equals, good. After the equal sign, Sabrina, do you think you know what to write in after the equal sign? So I'm here, right, and I'm here. What's left? 2, anything else? Yeah. C plus 12. Very good. All right, now, usually I go right to the distributive property. But there's something I can do before that. Anybody think they know? Combine like terms. Who said it? Ashley, what are my like terms? 76 and 12. You know what it is? 88. All right. I liked how Ashley didn't include that negative with the 76. It's going to be to the left of it to be part of it. All right? So there's no sign to the left of 76, so it's positive. What am I going to bring down to the right of that 88? Minus C, right? I'm just going to bring that down. All right? Equals, everything else comes down. Maggie,
Yes.
what do I do now? Nice. Good. Can you, I'm not going to make you distribute, but can you just tell me what number I will be distributing? Nice job. That's all I needed you for. Thank you. All right. So I'm going to do 2 times C, 2C. And I'm going to do positive 2 times a positive 12. Gives me a positive 24. Everything else comes down. Kyle, now what? I added C, right? I want to move we talked about this earlier, I want to move the smaller one. Negative C is smaller than positive 2C. Add C, and I add C to the 2C, bring my 88 down, equals 3C plus 24. 2 more steps, and I'm done. Ashley, subtract 24, why? Why would I subtract 24? And I want to get what isolated? Right. Isolate, I said it earlier, I'll say it again. Isolate means don't touch the variable. Leave it alone. Whatever's with the variable, that's what you want to get rid of. All right? So a minus 24. You said minus 24 from 88 too, right, Ashley?
Yeah.
All right, so I'm going to get 64. 3C. One more step, Bay, what is it?
You have to divide 3C.
Divided by 3, right?
Yeah.
All right, so let's get, 64 divided by 3 equals, ooh, didn't come out even, Mr. Hager, I don't like that. It's all right, we'll call it 21. How's that sound? All right, so we'll say, even though it's 21 point, let's say it was 21.3, we'll say C equals 21. Close enough if we rounded it. All right, so I got that done. Let me go back up to the top. I got 21 for Clyde. I'm going to write that in. I got to get James. What do? Ashley?
Use the first equation.
All right, so J equals 76 minus C.
Then you plug in,
Anybody know? Let me check. 76 minus 21. 55, good. Go back up, make sure I write it in. Good. So, that one was a little bit different for 2 reasons. What's one reason why it was different from the ones we've done so far? Can somebody tell me? What's one reason why it was different? Josh? Yeah, the past or the future sentence was at the beginning. All right? That was one reason why it was different. What's another reason why it was different? Nini?
The answer was a decimal.
Okay, we're gonna answer as a decimal. Okay, I'm thinking of something else in terms of the setup. Isolis? Yeah. Yeah, so in the I think what you're trying to say is, in row 1, all the ones we've done so far, we set it up, a variable is by itself, and we can just plug it in. This one, we had two variables on the same side, so I had to get it by itself. So if it says a sum of their ages, all right, if it says a sum of their ages, take what you're representing them with, take the letters you're representing them with, add them together, and it's going to equal whatever it says the sum of their ages will be. In this case, it was 76.